Thank you for this opportunity, and I'm delighted to be here and to be presenting some data that was collected from my lab about the developing of macular pigment reflectometry. This audience, I hardly have to say what's the use or need for macular pigment, but certainly serves as internal sunglasses, which will be probably very useful right about now with that light shining on my face. At this point, you're supposed to laugh. Okay, all right. So hard crowd. Okay, so amongst many things, the macular pigment optical density makes sure that the photoreceptors are actually protected, and 78% of Americans have lower than optimal levels of this particular entity. And the good news is that it is an alterable factor. It is an alterable risk factor as well, and it can be augmented with either good diet or supplementation. So macular pigment optical density has been associated with various diseases, AMD, cognitive decline, diabetes. It also helps the visual function or visual performance of athletes as well. So indeed, it's a very good biomarker, which if can be measured accurately and repeatably, will be very useful to clinicians. So there are devices that are currently available that does that, Macuscope and Quantify. These are very subjective in its nature. It requires pretty large amount of clinician or technician training, as well as it takes about 10 minutes for the person to perform this test and give you the results. So it's not very optimal in day-to-day use in clinic. Hence comes macular pigment reflectometer. Now, macular pigment reflectometry has been used in research entities for quite a while now. The underlying principles of the device is that you have a small amount of light that is sent into the eye. This light illuminates about a 1-degree spot in the central macula, and the spectrometer collects the light back from the retina, and that's where the magic happens. One can calculate and measure macular pigment optical density. Well, which is good, but not enough. Now you have the retinal signal back, and you can tease this out into individual components of macular pigment optical density, saying that the levels of lutein or the levels of zeaxanthin. And all this can be done with little or no instruction to the patient. If the patient can fixate at the light, you can get the data in about 30 seconds. So my lab was involved in performing certain preliminary data and validation studies. I performed the validation study where we looked at healthy individuals, and we looked at the repeatability of the subjective technology as well as the objective technology. And what we find is that the coefficient of repeatability of the objective technology is almost about 50% better than the subjective technology. You can also see that the levels of macular pigment measured by reflectometry is slightly different than the levels measured by subjective data, which just requires an offset correction. Now, as seen that the repeatability is good, 50% better, the pupil dilation indeed helps, because you're really talking of a very small amount of signal that's coming from a very small region from the retina, and particularly when you're trying to differentiate lutein levels and zeaxanthin levels, it's really, really close, so dilation seemed to be helping, but you don't require dilation to measure the gross macular pigment optical density. The interesting facts that came out from the study was that we found that the lutein to zeaxanthin ratios was 1:2.3, which is very, very similar, very close to the decimal point to the biochemistry and histological data that has been published. And so this gives us some amount of flexibility in perhaps tailoring our medications to our patients when they require treatment. The second study looked at non-clinicians using the machine, and as expected, we found that the machine was actually, or the non-clinician was actually reproducible quite well, showing good inter and intra-observer repeatability. So MPR has good inter and intra-observer repeatability. Pupillary dilation certainly helps, but may not be needed. Lutein and zeaxanthin measurements can be obtained, and technicians can perform this test with minimal training. So the goals of our final study that we are actually doing right now is to produce a normative or a reference database, produce some lens density whilst we're at it, and also create equations that can actually predict the data collected from other technology. So this picture shows the first prototype that was developed, which is on the left, and you find that the commercial prototype is available, and ZeaVision is looking for a commercial partner to develop this and bring this to market. Thank you very much.